Hi guys, so in this video I'm going to be teaching you about electric field vector. Electric field vector. So I'm going to explain why this is called electric field vector and how to solve questions on electric field vector. So the first thing you should know about electric field vector is the word vector. So when they ask you to find electric field vector, you should find the magnitude of the electric field vector and the direction, because electric field on its own is a vector quantity, so it must have direction and it must have magnitude. And the best way of knowing and understanding this concept of electricity is by solving questions. So let's get into solving questions right away. But before I solve questions, you need to know the formula for electric field vector. An electric field vector has formula. It is represented by this. It's represented by E with an arrow on it. So this is how to represent electric field vector. You know, anything that has arrow on it, it shows that it is a vector, because that arrow signifies direction. So they are trying to tell us that this is a vector, not a scalar quantity. So electric field vector is equal to KQ. This K is our the constant, which is 9 times 10 raised to the power 9. KQ divided by R square and R hat. That's KQ over R square times R hat. So this is the formula for electric field vector, right? So where our K is 9 times 10 raised to the power 9 Newton meter square per coulomb square. So that is the formula for K. The value for K. Then our R hat has a special formula, which R hat is the R vector. This R hat, it is called a unit vector. I know the magnitude of a unit vector is just 1. So to find R hat in our equation, you should know that R hat is R vector divided by the magnitude of R. So that's R vector divided by the magnitude of R. So let me explain these R hats for you. So let's say we have a vector, right? Let's say we have a vector that is, let's say, 2I plus 5j, and they say you find the R hat. The first thing you find is you have to find the vector itself. You have to find the vector, and the vector is this vector. The vector quantity is 2I plus 5j, because I and j signify that this is vector. This is the x-axis, this is the y-axis. So that's 2I plus 5j. That's R vector, right? But we're looking for R hat. So to get R hat, you need to get the magnitude. Then the magnitude will be square root of 2 square plus 5 square. That will give, let me type that in the calculator. Square root of 2 square plus 5 square. That will give 5.39, right? So our R out will now be the R vector divided by R. That's R vector will be 2I plus 5j, then divided by 5.39. So that's how to find R out. So let's go into solving questions on electric field vector. Let's go into solving question on electric field vector. Question number 1 says, calculate the electric field vector of charge Q. Charge Q is equal to minus 0.005 microcoulomb on the origin 0,0 of a coordinate system at a point. Then they give the point 1,2. So this is Q. This is where Q is. The point is on the x-axis is 1 meter away from Q. So this is 1, and it is 2 meters away from Y. That's 2. So this is where the point is, and this is where the charge is. So there are 2 ways you can find the electric field vector. There's a traditional way. Like when I mean the traditional way, like It's not, don't let me call it traditional way. The normal way we solve it, like the mathematical way, that's when we are using angle. So we can represent our answers in angle, and there is the unit vector way, like solving it vectorially. So I'm going to solve it using angles, and I'm going to solve it using vectors. So let's solve using angles. So to solve it using angles now, we have to find the magnitude of the electric field before we find r hat. So this is the formula. The formula is equal to kq over r square, then r hat, right? But let's find kq over r square first. Then E will be k is 9 times 10 raised to power 9 times q. The magnitude for q is minus 0.005, right? But we are going to put ordinary 0.005 because we are looking for just the magnitude. So that will be 0.005 over r squared. R squared. So what's r squared? R squared is the distance between Q and P. So to find the distance between Q and P, we use Pythagoras theorem, and that will be square root of 2 square plus 1 square. That's square root of 5, and that is square root of 5 is 2.24. So that will be 2.24. Alright, 2.24. So the distance will be 2.24 squared. So that will be 9 times 10 raised to power 9 times 0.005 times 2 divided by 2.24 divided by 2.24. So our answer here, we got 8.97 times 10 raised to power 10 raised to power 6. So that's what we got as our magnitude for the electric field. Oh, sorry, I made a mistake. This is 0.005 times 10 raised to power minus 6. This is in microcoulomb. So consider the microcoulomb. There's microcoulomb, there's a micro. The prefix is micro, so that's microcoulomb. That's times 10 to the power minus 6. So let's do it again. 9 times 10 raised to power 9. 9 times 10 raised to power 9. 9 times 10 raised to power 9 times 0.005 times 10 raised to power minus 6 divided by 2.24 squared. So that will be 8.98. So our answer will be 8.98 Newton per coulomb. Let me cross check that. So to find r hat now, let's look for r hat. So the formula for looking for r hat using the angle method is cos theta I plus sin theta j. And when we use cos theta I plus sin theta j, we are considering the angle in the x-axis. So to find the angle in the x-axis, that we need to use our tan SOHCAHTOA. So that will be tan inverse of opposite of our adjacent, tan inverse of 2 over 1. That will be the angle. So the angle will be tan inverse of this. So that angle will be, let's use tan inverse. Tan inverse of 2 is 63.443. So our r hat will be cos 63.43 plus I plus sine 63.43 j. So our final answer, cos 63.43 is 0.447 I plus sine 63.43 is now 73.43 is 0.894 G. So to write the final answer, this is the way you write the final answer. The final answer will be the magnitude times the R at. That will be 8.98 bracket 0.447I plus 0.894 G. So this is how you write it. This is how you write the final answer. This is how you write the final answer. So this is the final answer for the electric field vector. This is the magnitude and this is the direction. There's also another way for solving it if you don't want to use the angle method. So let's solve it using that way. So that way that's when we use this formula. We use this formula, this R vector divided by R magnitude. So the R vector is from here, from this. You know that the x-axis is 1, and the y-axis is 2. So that will be 1i, which is ti, plus 2g. I hope you can see okay. 1i plus 2g. So when you get 1i plus 2g now, let's find the vector. Let's find the magnitude. So to find the magnitude, we just have to square everything. We square the square of everything. Now we 1 square plus 2 square, and r will be root 5. And root 5 is, from what we got, I think root 5 is 2.24, right? Yeah, that's root 5 is 2.24. After getting 2.24, then we find our r at. That's the vector. The r vector itself, that's I plus 2j, and the magnitude of the vector, which is 2.4, divided by 2.24. So when you do this, we have 1 over 2.2, let me write it here, 1 over 2.24i plus 2 over 2.24g. So let's do that. 1 divided by 2.24 is 0.446i plus 2 divided by 2.24, that will be 0.893g. So this is our R at. This is when we solve it using the I and J method. That's the vector form, not using the angle. But if you notice something, when we use the angle method and when we use this I and J, you can see our answers are still the same. You can see that our answers are still the same. We use the angle and we use the I and J method, and we still got the same value for R at. So to write the complete answer is still the same thing. Just write the magnitude. The magnitude is still 8.9. That's 8.98 times 0.446i plus 0.893 joule. So it is still the same thing. Either you use the electric method, the angle method, or use the what are they calling it? You either use the angle method or use the I and J method. They are still going to get the same answer. So let's solve another question. All right, let's solve another question.